Another engine technology that we've mentioned a couple times but really haven't had a detailed look at is turbochargers and superchargers. And it makes sense now that we've got our heads wrapped around these PV curves a little bit to take this opportunity to look at them, because you can really see from the PV curve what turbochargers and superchargers are doing. So what is a turbocharger? So a turbocharger, you think about the words, it's charging something, and really it's charging the input. So basically what a turbocharger does is it uses energy in the exhaust that's going out of the engine, and it uses that to compress and shove more gas, more intake into the input side of the engine. So what does that look like? So let's there's a picture of a couple of them here. So this is what a turbocharger would look like, typical turbocharger there. You can kind of see a cutaway one, you can dig into it. If you want to get really impressed, this is a huge turbocharger on a performance engine and a pulling tractor. But right in the center here is what they do. So you can almost think of these as two, well, really is a turbine and a compressor. They talk about a turbine on one side and a compressor. Really think about it as two fans. So you think about a little fan that is sitting there. Of course, I can turn a motor on and it'll blow air in my face, but if I turn the motor off and I blow on that fan, I can make the fan turn. And that's really what the turbine is doing in a turbocharger. So it's taking the exhaust gas, the red hot gas that you see on this picture here, it's coming into one of these housings. So you can kind of see the housing here where the gas would come up into and start swirling around. So that gas comes in and swirls around, and there's these vanes in there, these turbine wheels of turbine vanes. Kind of looks like the vanes you would see on a jet engine, and it's the same kind of a concept. With those turbines there, the gases go through, they make those vanes turn, and then once they make the vanes turn, the gases exit out the end. So it gets that turbine spinning. So it'll start to spin pretty fast. They do spin it at a pretty high speed. Now, here's what's interesting is I connect the shaft of that turbine basically to another turbine. Now, it's different. It's a different design, but it's the same basic concept. So this is the fan, so I'm blowing onto this fan, making the shaft turn. That shaft is turning this fan, but this fan now is taking ambient air, outside air, or maybe an air-fuel mixture, but typically we see these on compression ignition engines. So it's taking that ambient air out of there, and it is compressing it and forcing it out. So it's actually forcing it into the engine at a higher pressure. So instead of that engine, the piston in that engine needing to draw a vacuum and pull that gas in, now I've got something outside of that engine shoving the gases in. So it's shoving that air fuel, the air in there, the air fuel mixture, so I can get more in. So here's the advantage. If I can get more air into that engine, I can put more fuel into that engine. More fuel with enough air to burn it correctly means more power. That's right. So that's what we're trying to do. So again, this is the concept. Exhaust gases turn the turbine, get it spinning. That turbine is connected to another turbine, which we call the compressor. That compresses the gas and it goes into the engine. So in the lower right here is kind of the whole system picture to see what it's doing. So here's my piston over here, the engine is running. The exhaust gas is coming out of this side. We can see the red hot exhaust gas moving this way. It goes up into this turbine and it starts that turbine spinning. So this gas coming out of there, it's moving fast. So you put your hand in front of an exhaust pipe on an engine, there's gas coming out of there. It's moving fast. So if I can capture that moving gas and also the temperature, and here's where you start getting into thermodynamics and you can get really, really deep into this thing. But this is also hot gases, and when I take a hot gas, go through something like that and through that turbine, the gas is going to come out at a lower pressure and a lower temperature. So I'm actually mainly taking the momentum or the pressure energy that's in those exhaust gases, but I'm also taking some of the temperature energy out of it. And that's spinning this other turbine, which is bringing ambient air in, and now that ambient air is compressing this gas, and that's coming around this way and going into the intake. So when this intake valve opens up, that pressurized gas is waiting to just get shoved down into the engine. So as that piston comes down, I'm getting more gas in there. I can put more fuel in there with it to burn it. Okay. So again, and there's some other things that we have on these engines, and we're not going to go into a lot of detail on this, but at least want to talk to you about that a little bit, because this is a thermodynamic process. So there's not just pressures of the gases moving through there that's going on. There's also some thermodynamics going on, some temperatures. So like I said, the hot gases coming into the turbine over here are going to come out at a lower pressure because I'm using some of that pressure up to turn the turbine, but they're also coming out at a lower temperature. So the exhaust gas on a turbocharged engine is cooler typically than on a non-turbocharged engine or a naturally aspirated engine. So we say an engine that doesn't have some type of a charger on it is going to be naturally aspirated. So it's going to be a little bit cooler. The exhaust coming out of a turbine should be a little bit cooler than the exhaust coming out of a naturally aspirated engine. But now the opposite thing is going to happen on this side. So as we take that gas in and we compress it, so not only are we getting that gas up to a higher pressure, it's also going to get hotter. So putting hot gases into the engine over here is not going to give me as much power output. So I really want to put cool gases in there so that when I ignite them, I get a big temperature change. That big temperature change is the energy that I'm pulling out of the gas. It gives me more energy out of there. So what I'll do sometimes is run that air through they call it here in this image, a charge air cooler. We often call them intercoolers or aftercoolers, something like that. So some different terms that you'll hear people use, and it's all slightly a little bit different in the engine technology. But the basic concept is, hey, this gas got hot because it came through this turbocharger. The turbocharger's hot, and I compressed it, so that made it hot. So what I'm going to do is just cool it off. So I'm going to use some of the coolant from the engine, the liquid coolant in the engine technology, run that through there, cool that air off a little bit before it goes into the engine. Then I get a little bit more power out of it. So not all engines have this. Not all engines have this aftercooler or intercooler or charge air cooler, whatever you call it, but some of them do. And again, that gives me a little bit more power. So the turbocharger will give me more power. If I intercool it, that'll even give me a little bit more power. So every little bit gives me more power out of that engine. So that's a turbocharger, basic concept. There's a couple links here when you dig up these, pull these slides off of the internet there. When you get those, these are live links down there. I encourage you to take a look at those turbochargers, and kind of shows you what they're doing. Some of those are performance engines there, and you can see that if the pressures get too high, we can have some problems down there. So there's one that's kind of a catastrophic failure. So that one's kind of cool to look at there. So I'd encourage you to take a look at those two videos in there. But generally, we're not looking at a lot of pressure in these things. So, you know, typical engines, 10 psi, less than 10 psi is kind of common. So that's not a lot of pressure. You have more pressure than that in the tires on your car. But it's enough to put a little extra fuel in there, okay? So that's turbochargers. Now, somewhat similar to that is what we call superchargers. Sometimes you'll hear people talk about these in performance engines as a blower, so my engine has a blower on it. So it's the same idea that I want to shove more air into the engine, but in this case, instead of driving it from the exhaust, these are typically driven mechanically from the crankshaft of the engine. So this is what the supercharger would look like. They generally sit above the engine. A lot of times these are going to be fuel injected engines, so they'll inject the fuel probably after the supercharger. So this supercharger turns, these lobes on here turn, that pushes air down through that supercharger, goes through. This one actually has an intercooler in there, shows the intercooler, but it goes down into the engine then, and the fuel is injected in there in a gasoline engine. So you often see these blowers on, again, racing engines that are running alcohol, high octane fuels and everything, so that they're shoving a lot of gas in there, so they're getting a lot higher pressure, so we got to have higher octane stuff in there to run. So they can be usually recognized pretty easily by these very wide belts. Again, this is a common thing that you'll see on performance engines, racing engines, drag racers, those kind of things. They have a big wide belt on the front with teeth on it, and this then is the supercharger that's right in here, or what we commonly call the blower. Again, all that's doing is taking air from this intake up there and shoving it down into the engine at a higher pressure. We want to get more air in there so that I can put more fuel in there so that I can get more power out of it. Okay, now the difference is with a supercharger, as soon as I start that engine, that supercharger is working. So it is injecting that air, pushing that air into the engine as soon as the engine starts. With a turbocharger that's operating off the exhaust, I really have to have that engine at a higher RPM. So I'll have to have the engine running faster so that that exhaust pressure can build up and the temperatures can build up. And that's why you won't see turbochargers on drag racing engines, because when that light turns green, I need my power right now to take off and get down that track right away. So I need that supercharger running fast, shoving that air in there. As opposed to if you watch tractor pullers, professional tractor pulling, that are using the big turbochargers, when they get the green flag, they'll sit on that line for several seconds and they open their throttle up and you hear the RPMs coming up on the engine, and it usually runs a little bit unstable, but you can really hear that thing winding up. And what's happening is that exhaust is getting hotter. It's building up that exhaust pressure, which is pushing more gas into the input, which gives me more exhaust coming out, which gives me more gas on the input, which gives me more exhaust coming out. And so it just kind of cycles itself and builds up, and when it gets up to the right pressure, that's when we cut it loose and get down the track. So it'd have to build it up. And in normal operation, so turbochargers on pickup trucks and stuff like that, they generally don't do real good at your initial acceleration. Where they really shine, where they perform best, is in their lugging ability. When I have that engine up to its operating speed, the higher RPMs, that's when that system is working, keeping the gases in the engine and really making me pull and giving me that lot of lugging ability, so I can take my pickup and haul a big trailer. It may take me a few feet to get it started off the line when my engine is running slow, but once I get it up to speed and those pressures are up, that's where it works best. Okay, so that's the difference between superchargers and blowers. Again, the concept, I'm putting more air in the engine so I can get more fuel in the engine, I can get more power out of the engine. Now, as promised, hey, we know something about these PV curves, right? Pressure on the y-axis, volume on the x-axis. So what does it look like? What's going to happen in there? So let's think about this. What did I do to this engine? If this is my normally aspirated engine, normally aspirated means no turbocharger, no supercharger, and I put a turbocharger or a supercharger on this thing, what's going to happen? Well, we know it's shoving more air in there. So what's the pressure going to look like down here? So here we said, hey, when that normally aspirated engine, when that piston comes down, theoretically, it should be about the same pressure as what the ambient air. So we drew that ambient air into there, so it should be about at that ambient air pressure. Well, now it's not going to be, because I've shoved more gas into that thing. So this is going to start at a higher pressure. So not an awful lot. Again, this is not a huge pressure difference, but it's going to start a little bit higher. The volumes are going to be the same. I'm not changing the displacement on the engine, so I'm not doing anything with the maximum volume, with the clearance volume, or any of that. That all stays the same, but what I'm doing is starting at just a little bit higher pressure here. And this is probably exaggerated even more than what it would look like in reality. Now, the shape of this curve is going to be the same, but since there's more gas in there, when I get up to this smaller volume, that gas that's in there is going to be compressed to a much higher pressure. So we're going to see this curve start out looking very similar, but when it gets up here to the other end, we're going to see it curve up much drastically. So the difference that I had down here was pretty small. The difference I have up here is going to be quite a bit bigger. So I'm going to get my pressures up. So right away you start thinking, okay, we got to watch auto ignition pressures and all that kind of stuff. That's why The racing engines that use the superchargers and blowers, they're using high-octane fuel. That's the reason they want to put ethanol in the fuel. And we'll find out later that alcohol is not as good a fuel when you look at energy. It doesn't have as much energy content in it, but it has a much higher octane, so I can shove more of it in there with a lot more air and run higher pressures. So now I take this curve and I got to that point and think, oh, this pressure started higher. There's more air in there, so I can put more fuel in there. So guess what? This is going to go really, really high. So here's the big advantage I get. So I get a big high pressure. So this distance from here to here was the normally aspirated with the amount in there. This is going to be much different. So if I take this same distance and move it up to here, this pressure is going to go much higher. So you're going to see that pressure go way, way up here on that ignition. So I'm going to get a much higher maximum pressure, and then that big pressure is going to be pushing on this thing all the way down. So now power. Do I get more power out of it? Absolutely, right? So, you know, this little bit down here is kind of a loss, but look at how much I gain up in here. So I gain a lot of power. Again, higher pressures, more air in there, more fuel in there, so I get a bigger pressure jump up here. So a couple things that's doing for me to give me more power out of it. Now, I do have to keep in mind that there's some losses because, again, with that turbocharger, it takes some energy to push those exhaust gases out of the engine and through the turbocharger. So I'm using some energy there to get that turbocharger running. Same way with a supercharger. I have energy off the crankshaft that's turning that belt to make that supercharger turn. So that takes a little bit of energy. But that energy loss that it takes to run them is not nearly as much as the energy that I gain by making this curve a lot wider and having a bigger area in between these curves. So this is not all completely gain, but it is a bigger gain, and we have to think through all that. So that's how we can look at technology. Now we have an understanding of what turbochargers and what superchargers are and what they do, but we can also tie that with what we know is going on inside the engine and see, oh, that's how we get more power out of it. That's how it works. It's not just the air that's going in, but it's also the more fuel that I can put in there because I have more oxygen molecules that they can burn.